So basically, I want to talk how I'm basically using JIRA as a way to make application security very rational and very objective. My point is that I don't want application security to be attacks. I don't want us to be something that the developers don't want to involve with, something that doesn't have any kind of real stick. I want it to be very objective, but I also want it to be in a case where we say yes a lot of the time. So my view now is what we do is from AppSec, we say, hey, you want to do X? That's great. Here are the consequences. Here's the pollution of it, right? So I will expand on basically that. So, it helps if this guy's plugged in, right? So, and I'm using JIRA, and there's a couple of other options. I've actually used the same thing in GitHub. You can kind of use a couple of variations of it. I think JIRA, because of the workflows, is quite well known. Also, just about every company I know has JIRA, so it kind of helps. So here we go. OK, so I've been developing for a long time. I've been AppSec for 13 years. I've done the O2 platform. I do quite a lot of training, so I do about 1 to 2 days of training a week. I train a lot of developers. My training strategy, which I highly recommend if you guys want to do training, is basically we go and hack their applications, right? Because you have the developers in the room, so I go say, hey, let's look at your apps, right? So it's actually a great way to actually make the paradigm shift for developers. I also are part of a couple of AppSec teams. So the HUD Group is a very interesting UK company. They're kind of a big company. I'm doing some stuff to BBC, and I'm also mentoring a couple of other companies. So I've kind of wrote a couple of books for my blog, which you can get there. You don't need to pay. You can just go and choose a free option. I'm also kind of writing. I'm trying to dump all my knowledge into that one, measure software security and quality, and I'm doing this thing. I'm revising this book because of the Angular project that I'm going to show you now. So again, if you guys want to check out, so all the content is on GitHub. It's all freely available. It's in my blog, my tweet, etc. And then you might want to check this presentation I've done for some developers. That one actually has 250 slides. It's a bit bigger. This one only has 80, right? So, but I kind of talk about this new year of model development where you can actually use application security to measure and define software quality, which I think is a very interesting concept because this is this kind of stuff you do when you do application security. If you look at it, there's a very direct correlation with what you would do with development. So the way I look at it, if you're not doing this, you can't even do security, right? And in most companies that I know, they don't have a security problem. They have a development problem they need to fix. They're not even ready to start to do application security because they don't even control or have a very effective development environment, right? So again, this is the stuff they need to do to make AppSec policy. I really like the pollution analogy. If you guys, this is actually was inspired to me by a presentation for David Rice, which now has gone to the Apple black hole, so you never heard about the guy again, but it's a spectacular presentation, and he kind of makes a great case of pollution in AppSec. And I really like it because it's way better than technical debt, because technical debt is paid by the developers and by everybody else except the people making the decisions, right? So I think pollution is way more interesting way to measure. But that's another presentation you guys want to check. So AppSec and developers, right? Just a couple of disclaimers. I totally abuse the term unit test. So it depends on where you sit on that spectrum. It might freak you out in the beginning. For me, unit test is anything that can be run with one of those frameworks, and that includes from Mocha and JUnit all the way to Selenium and the massive integration tests you can think of, because for me, the only interesting question is how big is the unit, right? And in fact, the way I look at it, the more unit of the test you can run in a fast and effective way, the better it is. Because the more state you have, the easiest to maintain, the more reality you have, and the more you have to not rely on mocks and all that crazy stuff, or even not do it, right? Again, I abuse the term risk. So depends where you fit. You might have a massive heart attack, how I use risk. I kind of try to find a word that sort of fits all the stuff we do, and risk is it. So for me, anything that moves in AppSec is a freaking risk, right? It kind of fits within the build. You rewrite a little bit, but again, it's kind of the concept of it has some security implications, it has some behavior, right? So it's a risk, right? And I usually create a JIRA call risk. So you have JIRA risk 1, risk 2, risk 3. It's just a nice little term. Again, when I talk about 100% code coverage, some of developers freak out because they start to argue about the technicalities. For me, it's not even 100% code coverage the point. That's not even the objective. That's like base camp on the climb, right? You need 100% or 95% code coverage to do in Java because Java is a bit screwed up, right? It doesn't allow you to do code coverage properly, right? But you need that because you need to be able to test the application from all sorts of different angles. It's only when you have very high degree of code coverage that you can play a whole number of games and develop environments and security tests, right? So again, and I view AppSec as kind of equivalent to non-function requirements, right? My definition in a way of application security is basically about understanding and controlling the application's unintended behaviors, right? So if an application has a particular behavior that it's not supposed to have, for me, that's a security issue, right? That's where I kind of lie AppSec on all these kind of non-functional requirements, all these extra properties that the application has to have, right, in order to do what it wants to do, right? So again, this is AppSec. So AppSec, it's about code, AppSecEU coding standards, threat models, frameworks, code dependencies, QA testing, fuzzing, all that jazz. InfoSec is about networks, firewalls, server monitoring, all that jazz, right? The InfoSec, again, it's very important, right? You have to have it. It's actually one of those cases where I don't think I've seen an organization that has AppSec, it doesn't have InfoSec, because it's kind of like they're dealing with the first basic kind of stuff, right? And, but the best way for you to determine if you have an application security team is ask, can those guys program? And the second question is, would the developer team hire them, right? So if your developer team will not hire the guys that currently do AppSec, right, from your InfoSec team, then you don't have an InfoSec. So you don't have AppSec. You have some great guys, but they're not really doing application security, right? And again, of course, it's very important. You knew that stuff, right? And I actually seen some of those guys use this because, again, the InfoSec guys also have a lot of problems with risk management, how they control it, and so they actually use some of the techniques I'm going to show you here. Now, who's a developer here? Who's like a core developer? All right? All right, cool. So basically, you guys need to join AppSec, right? It's that simple, right? I really like that quote. It's kind of like one of those Twitter exchange, but it kind of, I think, came out really well, because I always try to justify why I think I'm a better developer because I've done application security, right? I don't think I'm more clever than most of the developers I meet. I think I see the world a little bit different. Because when you do AppSec, literally you have so many cases where, you know, you start with something like, oh, you can do that, right? But in AppSec, that's really the first challenge, right? Then you go, well, you're not supposed to do that, right? And then eventually you go, hey, I just did that, right? So that's your world. In AppSec, you know, you view the world a little bit different. You view it more three-dimensional. You kind of have a much more interesting definition of where the lines are, right, of what you can touch and what you can't touch. And as a developer, that gives you all sorts of great stuff, especially when you go into testing, because with testing, you have to sometimes be very creative to actually put your payloads in the right place, right? So, and again, you'll be paid better, right? Because at the moment, right, there's a lot of massive shorted gap, right, in application security because we can't get it, because the problem is most of the guys who come into the current application security space, they come from the network security space, and they're totally screwed because they can't program, right? So it's much better to take a developer and make him AppSec than make, you know, a network security guy making AppSec. That's just not going to happen, right? So again, if you're a developer, great time, join InfoSec. You do an OWASP conference, that's where, like, you know, that always should get you a job, right? Because you go to some companies, and that already puts you a bit above, right? So I'm going to talk about this maturity model application, which is basically, it's open source. It's something I've been working on now. It's based on a real-world mapping of BSIM, and now it's going to be OpenSAM, right? It's going to be compatible with OpenSAM, and it's actually coded in Node.js and AngularJS. What I find interesting is I actually had a great case study to talk about the stuff that I want to show examples of, but in the past they were kind of in real bugs. So you can't really show companies real bugs because they don't have a good sense of humor, right, of you actually showing their own vulnerabilities in this kind of stuff. So I decided to show you vulnerabilities that I created so I can walk you through this workflow, right? So you can do this kind of stuff. It's a nice little graph, and this is kind of like how you map. So the idea here is, does that guy work? Well, look, can't see that, right? So the idea is that the green thing, or the orange thing would be, actually, I just thought something very funny, right? Does anybody here see that guy as not orange? This would be funny, isn't it? Everybody sees that one orange and the other one green? Hey, you never know, right? with that one. All right, so the idea of this one is you have a baseline, that's what the company wants, so that's level 1, level 2, and then you can track your answers, and you can say, hey, this is where I kind of suck, or this is where I need to work better, right? And then there's a nice web interface. So again, I didn't want to have to fill it with spreadsheets, so I kind of create a nice web interface where you can click on things, save it, and then you create these kind of little graphs, and then you can navigate by projects. That's actually the vSIM sort of OpenSAM stuff, which is cool. That's actually all the levels already mapped. And then all the data is on JSON, which is, again, is pretty interesting, right? And on this one, I'm making the security champions the one responsible for this data, right? So, and again, you have a nice mapped attack surface because, again, I'm doing security. I need to test it, so I'm going to give you the attack surface on a plate because I actually need that because I need to do for my tests. So, okay. So there's actually pretty cool continuous integration. If you guys want to get your heads around continuous integration, this is how it works. I push my code to GitHub. GitHub basically sends a webhook to Travis. Travis is going to clone it, run the tests. If it passes, going to build a Docker image. If everything passes, puts the Docker image to Docker Hub. Docker Hub basically is going to run it. It meanwhile, also creates a clone for my QA fork and sends an extra commit to it. So by now, Docker Hub is going to send a webhook to Docker Cloud, who's going to contact the mapped DigitalOcean option. So that's like the kind of one of the providers. It could be AWS, could be Azure. I just use this Ocean because I like it. And then pulls the image from Docker Cloud. The container starts. Meanwhile, the my QA fork is starting with sends a webhook to Travis, and that clones the repo and runs all the QA tests against the deployed thing. So this is pretty cool. That means that with one commit, I'm running all my QA tests, all my application tests, all my web sort of Angular tests, and then I build a Docker image that immediately gets pushed to Docker Cloud. I clone that, put it on the live server, run all my QA servers onto it, actually run a set of performance tests on it, right? And only if that passes, I haven't done that yet, but I'm actually going to push into live production, right? So that's the flow, right? That's the kind of stuff that you want. The way I look at it, if you don't have this in your environment, as a developer, you're not effective, right? So with this, I'm deploying 5 times, 20 times a day, 30 times a day, right? That's what you want to do as a developer, right? So what's interesting is I actually decided to map every single technology I'm using, and that's the whole shopping list, right? And this is not even a complicated application, right? Then you wonder why it's hard to protect all this stuff, right? So I'm actually trying to document all that into that book, right? Now, first key concept here, right? The way application security scales in an organization is to have security champions. Now, some companies like to call them security advocates. I'd like to call them security chapters, whatever. Every team needs to have a person that is responsible for security. This is what's very important, that it's not a manager, right? This is not the person, in a way, the architect. In fact, it's very important that this person should not have decision power, right? This is basically somebody that has the time. You should spend at least 1 day a week, right, on security, and that's why I also make it security testing, because I think that's an area that's quite important for the team, and that's somebody that has the time to do the security task. That's the security contact. That's how you scale. That's the first person that you start to ask a question when you have kind of a security thing. So there's a quick description here, and the slides will be on my blog, and it will be published so you guys can see this in more detail. And this actually comes from that blog post. But basically, that guy's participate on AppSec Wiki, collaborate with security champions, goes to the weekly meetings, has single points of contact, ensures security is not a blocker, and assists in making security decisions for the team. And the key one is the last one, help with QA and testing. What I found is the sweet spot with dev teams, unless they've been attacked, right? So if your company's been attacked, it's a little bit different because you then have a nicer mandate, right? Even that kind of depends on the memory of the attack. But the way for me to scale application security is to have these guys make the application better in a way that is better tested. And that's where we inject, in a way, our security tests. And the security champions are perfect to do that kind of stuff. Now, if you don't have a security champion, right, a great trick is you get a mug, right? Like that, and I've done this for a couple of companies. You get a mug, you maybe find a mascot for the company, put a nice massive spliff in there because the guy's really stressed, right? And then you write security champion, right? Maybe in the back, I see some guys writing, it's me or Stack Overflow or Google, right? And then you give that to the team so they can put that on their desk and say, hey, that's the guy that we talk to when we have security questions, right? And that is actually a very interesting social engineering, because it reminds that if that dude doesn't exist, right? Who do you talk to, right? And I usually say that there's 2 requirements that you need to have to become a security champion in a company, right? Because sometimes security can be far overwhelming. People think, oh, I'm not good enough, that's way too much kind of stuff. So the way I look at it is that if you have a heartbeat, right, and you work for the company, you qualify, right? That's the first baseline, right? Eventually, we're going to zoom in on that one, but every team needs to have one of these. And I would say if you're a developer or part of a team, step up, because guess what? Nobody's doing, right? So it's a great place to do. And the thing that is also very important is you will need a central security team. You will need those centers of expertise, and part of their job is to put energy into it. Part of their job is to make things up. I get stuff, look at something, hey, you did that, really cool, come and present. So in a way, the weekly meetings that I tend to organize, everybody's presenting stuff, right? So it's not about, again, the security team telling people what to do. It's about each security champion presenting something that they've done in the last week or so. So some companies I've seen do every month. I like every week because, eventually if the company's big enough, there should be stuff going on, right? Okay, so now let's talk about the JIRA workflow, right? One of the key problems that I always have when I was doing security is that you have this massive black hole where things go, right? And it's kind of like security knowledge doesn't scale, doesn't stay in one place, and more importantly, the people that are making the real decisions are not accountable for it, right? So this is, for me, one of the ways you do that. So it's kind of like we're hacking the organization to do the right thing, right? By putting responsibility. So the workflow is you open JIRA issues for all AppSec stuff. And I actually put the bar really low. For me, if it's unintended behavior, it's a security issue, right? If you don't understand something, it's a security issue, right? If I ask a developer, where are your controllers? If the guy doesn't know, that's a security issue, right? Everything you find in a pen test, all those are security issues, right? A question about how something behaves, if nobody knows the answer, that's a problem, right? Because the next time somebody actually needs to find that for real, you're going to struggle. And what you're doing is you're putting lines in the sand. So you can say, hey, there's a massive kind of problem here, right? So I'm going to identify that massive problem, so when that blows up, I can point to it, right? And that makes a massive difference in the organization into it. Then this is kind of, it might take your head a little bit to get your heads around this, is that actually depends how much TDD you've done, right? But the logic is for every issue that we open, we need to create a test that passes when that issue exists. Because what we're doing is we have a test that represents a feature or a behavior or something, right? So the bottom line is that an application has SQL injection, that's a feature, right? It's great. I can do SQL commands directly from the outside world, right? That's pretty cool, right? The application has no authentication, that's great. That means that these web services can talk to that guy without even bothering. Really cool, right? I guess maybe one day we want to connect that to the internet, ooh, that might be a problem. Or maybe when you have, for example, a server-side request vulnerability or other vulnerabilities, that's a problem because now you can talk to that guy and then hold the customer data. But guess what? Until that, that's a feature. So the way I look at it is you want to have tests that prove that stuff, right? And that's the flow. And then you manage them using the risk workflow that I'm going to show you, right? And there's only two paths. This is absolutely critical, right? There's a path where things are being fixed, and there's a path where things are being accepted. There's nothing in the middle. Issues don't kind of just stay. They either are on one path or on the other. And I tend to prefer Kanban for the fixed path because you can measure the work in progress, kind of the flow, right? And this is the best part. Once you have everybody accepting the risk, you put them on nice little automated emails that goes into them and goes to the CTO and all the way up to the CTO. Because in a way, one of the key concepts here is that you want everybody to make sure that it's their boss who gets fired, right? So that's kind of a really cool model, right? And because somebody has to take responsibility. And it's not the developers. It's not the developers who have to take responsibility by the fact that they just created a massive security vulnerability, right? Unless they did it on purpose, right? And that's a bit of a different story, right? But because most of the time the developers are constrained by the environment, by what they had to do, by crazy briefs, right, etc. Right? So here's the workflow, how it works. What you got? So this is kind of created in JIRA, and then the power of JIRA, you can make this all go automatically, and I'll show you how it works, right? So you can see kind of on the right-hand side is the fixed path, right? So you create the thing. The kind of closed is there because you might have some false positives. You might have somebody to say, hey, look at the answer there, which is a great way to educate somebody. Hey, why don't you look there first? Right? But actually, already you documented something. You said, actually, yeah, that document that we can never find? It's here. There you go, right? That mapping or that stuff, it's here. So now you create this information, right? So all that is very, very valuable, right? So then you create a powerful allocator for fix. Then you kind of should be fixing a couple at a time. Ideally, you should write a test for it. So again, I kind of have the fix there initially because, I barely get sometimes this to work. Might as well if I put a requirement that every freaking fix has to be tested, right? And we have a way to prove that. So again, go gentle on it. But in the beginning, you should not allow anything to be marked as fixed unless you have a test for it. In fact, what's really almost beautiful from an application security point of view is when you can review a security fix by looking at a test, right? And that is great because what it means is I wrote a test that represents the vulnerability, so that is a feature. Part of the fix is to change that test. So that test now passes and is a regression test. Right? And now I've been in a situation where I can look at that test and know immediately if they fix it okay, if I have bigger problems, or if the fix is totally, right, out of whack, which what I actually seen in the code, right? So that is actually quite important. Now, the acceptance risk is where the real magic occurs, right? So this is where you go, you put into that state of awaiting risk acceptance, and then the risk accepted is this button, right, that the managers have to press. Right? And I've actually been reading quite a bit. I always like the whole psychology stuff in the brain, and there's actually something interesting that happens when you make something physical, when you actually physically do something, click a button, sign something, right? At least even just, just move that, right? There's something in the brain that goes, ooh, okay, whoa, I'm going to be on the record here, right? So it's very important that that occurs, right? Because what you find is most organizations, like, you have these devs who are totally frustrated, right? In fact, sometimes you just need to like give them a couple of beers and you can just write all the issues, right? Because they know all of them, right? And they've been banging and they lost the fights and they jaded, right? And they gave up. They go, you know, if you're not going to fix those holes, then what about these ones, right? So it's very important that you create this system where you document all that and then you go to the business owner and say, hey, dude, click here, right? And I guarantee you that's the first time that those guys actually hear what you were saying. Right? And that's fine, because for me, that's part of the design. Like, I know that the management and the business owners, the only time they're going to pay attention to what we're telling them is actually when you do that, right? That's cool, right? That's part of the flow, right? And there's a little variation here between the risk acceptance. If you see that risk acceptance and the risk approved, that also is the step where the security team, backed up by the CISO, backed up by policies, say, hey, actually, we're not going to approve that. Actually, we're not happy for you, Mr. Business owner, to take that risk. In a way, what we're saying is you need to argue up the food chain. And sometimes that's fine, but usually that's the moment where they go, ooh, let me rethink this a little bit, right? Because ultimately, the way I look at it is that if the AppSec says you can't do that, it's not because we're in a bad mood or we don't like the guys, it's because there's a reason, there's a policy, there's a requirement, there's a consequence that will happen if you do that, right? So this is a great way to be pragmatic. So what happens is sometimes the risk is not approved and it goes back to allocated for fix. I had one of these where we were providing a white label for a company and basically the client turns around and says, hey, we want to drop SSL because the advertisers told us that it's cheaper for us if we don't do SSL. So why don't you just do SSL and that login bit over there, right? Pretty cool. So the business owner accepted it, the developer was implementing it. Because he opened up the issue, we picked it up and said, ooh, hold on, no, we're going to have to talk this at the higher level, right? And when we're back to the customer, they backtracked because, they realized that actually that was not as straightforward and here was the implications. We actually heard that the client really liked, the real client, like the boss of that guy, really liked the fact that we defended and made a good case for making security. All right, so here's the fixed path. So this is how it works, right? You come in there and you basically say, hey, I have this issue here where, I have this data transversal vulnerability, which I'll explain in a second, right? So in JIRA, you create a ticket, and now if you see there, so I was going to point to that thing, but I can't, right? Can I move my mouse? I can't too. So, okay, so if you see there, just below the path transversal, can you see that button that says to in progress, right? So that's the button. So the idea would be you create the issue, and for me, it's key that the bar of entry is really low. It's key that you don't force the person that actually is reporting the issue to really be accurate. Because what I found that sometimes all you see is, I like to see is like a shadow of an issue. You don't really see the thing. You just have an instinct. You go, oh, this doesn't feel right. In fact, me as a developer, that's sometimes how I feel, because when you program, you have a very thin slice of the code in your head. The mental model that you have is very small because it's about the issue you're fixing. But you look at something and go, this doesn't feel right. Ooh, I shouldn't be doing this. But you don't have the time. Capture it. And when you open an issue and nobody has the time or the understanding to add more detail, you open another issue saying, hey, those guys don't understand how things work, right? That's fine, but that's part of the game, right? So then you go into in progress. Then again, you're going to click that button that says allocate for fix. Then you're going to click on the button that says I'm fixing it. Now, usually what happens, and I'll mention this later, but it's important, this should exist on its own JIRA ticket project, because you don't want to be involved in the politics, right, of each project. Each project owner has politics of how they open issues, how many they open, what's the flow, so don't get involved in that. Usually, this is the time when you create a ticket on the other side. You go, oh, I'm going to fix it. This is what needs to do. And sometimes, actually, one fix has 4 or 5 changes, right? Or sometimes the other way around. So one change affects 4 or 5 things. So it's important to have this asymmetry. Now, when you fix, you should mark here for test for fix. And this is where I would expect to be able to read a test that shows me the proof that the fix exists, right? So that is quite key. And eventually, you mark it as fixed, right? So that's that workflow. Right? And in here, what I think is very key is that you don't have a lot of stuff on fixing. There should only be 2 or 3, right? Because that, again, you should measure the speed of that thing. And also here on allocated for fix, you don't want a massive shopping list, right? So if things are staying on a shopping list in there for a long time, then you actually will have to accept risk, right? And I've seen sometimes this happen. They go, oh, yeah, we should fix that. Yeah, we should fix that. Yeah, we should fix that. You come back a month later going, hello? Have you fixed that? Oh, no, it's not a priority. So, okay, fine. Then you're going to have to accept risk. Right? So they should never stay here for much longer, right? In the thing, right? So now let's look at the path of risk acceptance, right? So this is, for example, an issue I have at the moment, this application supports CoffeeScript files to create dynamic data, right? This actually means that this application has a built-in way to do remote code execution as a feature, right? That's a feature, right? You can upload, like, actually, by now, you can do remotely, but as a feature, you can actually, if you control the data thing, you can actually put code in the server, right? So it goes here, it goes to in progress, then you click on request risk acceptance, so now you're on this left side of a tree, and there's that magic button, accept risk, right? Actually, I would love to find a way in Jira to make that really big, right? Kind of go, hey, here it is, man, there's the one, don't miss it, right? And, but even like if you click it on behalf of somebody else, it's fine, it's assigned to somebody, right? In fact, on one of the projects I was working, we actually added an extra field to the right that says assign to, just to make it really explicit that it's that guy there, right? So, and then again, you accept the risk, so then it goes here, then AppSec or InfoSec approves it, and then that goes in there, and it kind of stays there. Now, what's key is that it doesn't stay there forever, right? So when you fix, in principle, it stays there forever unless you kind of have some, what's it called? You know, it reappears. But here, everything that's been approved eventually will expire, right? So you can do this automatically. You can do this every couple of months. You can do this manually. The logic is you have to revise it again. You have to ask the question, was the assumption that we used when we approve it still the same? Have it changed, right, across the board, right? So that, again, is very key of this workflow to do that, right? And the cool thing is that, very important, is everything is tracked, right? So you know exactly when was done, when was requested, and in a way, that's the bottom line, because that's when somebody actually made the action, and you got proof that it happened, right? So here's a case study of when I created a vulnerability, right? So here's the code that I wrote, right? Because the feature was, this is when, you remember that when I showed that bit where you can edit the things? So this was the feature that was added. Like, hey, I can display data from a JSON file, I need to edit it, right? So this is CoffeeScript, by the way, so if you guys, for me, it makes JavaScript sane, right? It has classes, all sorts of interesting stuff, right? And in fact, E6 looks very like JavaScript, so like CoffeeScript, so one of my favorite languages these days. So bottom line here is you get a file name, you get some file content, checks if it's null, checks if it's string, you know, tries to find it internally. If you can't find it, actually combines with the data path, and then it saves it, right? So basically, the bottom line with this thing, you can create any file with any extension anywhere in a file system, right? Not a nice little feature. Now, what's interesting is most devs and most security teams will not consider this to be a security vulnerability because this is an internal function, right? This is the equivalent of having a function that, you know, maybe allows SQL injection, but it's private, right? So it's still not directly exposed to the outside world. In my book, that's a problem because that's a vulnerability waiting to happen. That is pushing the callers of this to understand the side effects of this, right? So for me, that's the problem, right? So what I do is I create this issue. So here's the implementation of that thing. I write a test straight away that proves the problem. So this is a passing test that is going to create a file on above the folder, right, where the data thing exists, put some value on it, call the method there, right, that populates it, and then confirms that the changes actually exist. So this test passes when the vulnerability actually is there, right? And that's the flow, right? So then what's interesting is I start to look at it and I go, whoa, I actually have a denial of service by the file name because I can put a massive file name on it, right? And here's my regression test, my security test to confirm that I have that vulnerability, right? Here is, again, allows the creation of any extension. There's my test. So these are all security issues that are related to that function, right? And then there's another one. I edit the files. That's remote code execution. There's my proof that you can do that. And so all of those are issues that I've documented for that feature, right? So the logic is you added a feature. You know, ideally you had done this by threat model initially, but I added a feature. That feature has its issues. I've added those issues as basically entries to my bug tracking system, and I created a test that proves that they exist, right? So what happens is basically, so that's the fix for the path transversal, right? And there's my regression test for the path transversal. So this is the same test that you just about see here, right? Here, right? So this test is, is the same, is a variation of this one, except that the first one was showing that I had the vulnerability. This now shows that I don't have the vulnerability. So in my book, the tests always pass. So I can look at this and start to say, okay, cool, my payload now doesn't work, right? So now let me show how this looks in the code. And again, the same things that you do when you actually put the, something physical makes a massive difference. So here's what it looked like before the vulnerability was created. Here's when we added it. So this is the source code when he had it. The first thing you want to do is you want to add some to-dos, right? So I think it's very important that you don't shift context. So at this stage, I don't have the time and the mental energy, right, to go and do a security analysis on that code, right? Because I'm fixing that particular problem. I'm fixing a problem on how to edit files on the file system. So I sprinkle my code with all the things I want to add back. And when I do it, it becomes like this, right? See, so now I sprinkle the code with the issues that exist on the application. So I'm still aware of it. And anybody that consumes it, it has access to it. In fact, I've seen some really cool stuff where you use, for example, JDoc, the Java doc stuff, and you actually put the comments in there so the consumers understand the side effects of that. Hey, be careful because the UI cannot validate this. Ooh, be careful because there's a SQL injection down the road. Ooh, be careful because the next layer is not able to handle data here. So if you put malicious payload here, then you're screwed, right? Or like the things like, hey, there's a Java serialization on the other side of this method, right? So be careful if you feed something that Java serialization to that side, you now have a problem, right? So again, I improved some comments. Now what's interesting is so the difference between this version and that version is I fixed a couple of vulnerabilities. So now you can see that the things at the top changed. Now I have other issues that I've identified. And finally, here's the final version that only has one issue, right? That still exists, which I have accepted, right? So, and that's the flow. At this stage, all those issues were on my to-do, my fix file. But now my 26, which is basically I can do denial of service via the file contents, is actually currently an accepted risk. Because you feel like, well, we have a lot of these space, you need to send a lot of data on the network, it's kind of okay, right? So that is how all that JIRA workflow stuff relates back in the code. You correlate and you link back to the code. So key concepts for the JIRA workflow. The first one is that button, right? That button is the one that really makes a difference, is when you make somebody accountable. And again, it's the business owners that click on that button, right? So you have a separate JIRA project. I usually like to call it risk because it avoids the kind of issue creation issues, and also gives you a safe harbor for known issues, shadows of issues. This could be a problem. Ooh, the app is still in development. That's the really funny one. Oh, it doesn't matter because we're still in development, right? And then you have the curse of success, where you spend 3 months creating a proof of concept, and then you're going to make it live in a couple of weeks, right? Or even a month. But by then, the game totally changed, right? So you want to be in a situation where, yeah, it's still in development. Here's my 25 things, right, that I still haven't done, right? Or my security properties. Right? So again, when deciding do you fix an issue, that's usually when you create on the other side. And when you fix, you actually come back and confirm the fix and close this risk. Right? So again, the issues are always moving, right? So they're either on the fix path, on the risk acceptance path, and basically they're never in a backlog, which tends to be the problem. They go, oh yeah, we'll deal with that later, we'll deal with that later. You only handle the top issues, and then you have all this pile of stuff in the backlog. Right? So the key is that if it's stuck in allocated for fix, then you move it into the risk acceptance stage. Right? So you need volume. Right? This is one of those things where it's very scary when the first application to do it, because it feels like, oh, you're calling my app names and you're picking on my app. The reality is until you have like 350 issues, you're not even playing. Right? You need a lot more. You need volume, because first of all, that removes the stigma of having issues, and also gives you a lot of core examples. So allows team A to see what team B had, and they can correlate. Much more important, right, is the fact that once you start to really think about it, your problem is not his team that has 50 issues and they're working through them, and they're cleaning them up, and they continuous improvement. Your problem is his team that they're handling highly critical stuff, and when you talk to them, you go, hey, do you have any risks, any worries? Nah, it's all cool here, right? And you go, yeah, but you talk to that asset. That is a really big access for the company, right? How come we don't even have an awareness that you're talking to asset, right? So you always find that the teams that have no security risks or no security stuff is the shopping list, right? You find like the OWASP top 10 on them, right? So, which is interesting. That's why, again, you need volume, right? And again, this is perk for gamification, because you can reward the people who find more stuff. You can reward the devs, send them to conferences, all sorts of interesting stuff when you have this, right? So the threat models, again, that's actually a massive area where every issue identified in threat model is added to the risk project. These days, I've found that you create threat models by layer, by feature, by bug, which works really, really well. But that's a topic for another talk, right? So, but it all correlates to that thing, right? right? And I actually am a very firm believer of kind of manual stuff, so I sit with devs, they write the thread models, we digitalize them, we come back to them and going, hey, here it is, right? And we tend to use Draw.io and Visio, so Draw.io is quite an interesting one because it saves in XML files. So, but again, this all correlates to the JIRA stuff, right? So all the threads that we identified are mapped into JIRA, right? So there are the things, so you can add labels, you can map the stuff, you can use all sorts of interesting properties. Here's the mapping of the JIRA ticket to a test. So for example, I'm missing the HSTS header, I can run it. Here's my test that confirms that I currently have a missing HSTS header, right? That's the proof, that's the loop. You create these nice little dashboards with basically with the risk acceptance, with the allocated for fix, what you accepted, what you test, and you send these nice little emails to management and everybody in the food chain to say, hey, this is still real. And sometimes what happens is the current manager is okay, it's the new guy who inherits the application and goes, whoa, what the hell? What is this, right? And then they want to do stuff. So again, it's a game, it's being played, you might as well modify it, right? So again, a couple of interesting features that you have with JIRA, you have the components, which you can use one per team, labels, you can link stuff, you can send auto emails, copy and paste into descriptions, markdown, secure restrictions, which you can, again, I would recommend that you share the information, right? You know, again, there's no point in having all these silos. The best description I've heard was these guys that said, if the house on fire, you fix it and you document it, everything else you document it because, hey, guess what? That information is already known, at least we make it clear that we have those issues, right? So, and sometimes what you might want to do is create a special AppSec JIRA project for tasks. So it's kind of like, again, don't pollute the risk with that. So things like create a threat model, do a security review, do something, create document, create this. You keep it on a separate kind of project, right? So you can do the same thing with kind of GitHub, which actually what I was doing there. So you can use the labels that I was using. You can see that you can then use the labels. And it's the same thing, you know, there's somebody has to physically go in there and press that button, right, on GitHub. Same kind of flows, right? So this is, for example, all the issues that currently exist on the application, right? This is every single issue that at the moment, right? So that's actually the ones that has been accepted, right? Actually, most of them, so actually, there's a couple here right, on the fix, right? So but you can see things like the web root is exposed by API, the logs are exposed, you can do denial of service right there, you can edit the files. So this is basically, there's no data classification assets used. So this is me mapping the current state of the application. So there's no authentication authorization. The web servers are exposed, right? So you have to take that into account, right? So if you want to use this product or this tool, you understand that there's no authorization. That's fine, right? As long as you acknowledge it, right? So, and again, that's the ones we fixed, right? So again, I was using the risk fix, stuff like that, right? So that's just an example of what it looks like. There's the thing, there's the code, there's the test, and there's the actual physics, and there's me saying accept risk, and you can see that you track there, and in a way, again, you get that ability to track the information, right? Final little thing, right? For TDD to be productive, which is, again, the other massive part of this workflow, right? You need real-time unit text execution, basically when your hands take off, and real-time code coverage, which basically means that, you know, you need to be run, you know, for that to exist, you have to make developers more productive and prevent developers from switching contexts, which is what they do when they basically have to move from their IDE and test something, right? And TDD is key for this whole workflow because that's what allows the tests to really be created, right? And again, if 90% coverage is not happening, it means your TDD is wrong. Right? So here's my IDE when I use. Here's, for example, a question. What happens when you increase the attack surface? Right? This is a very key question. Users, I'm going to increase the attack surface of this application. I'm going to add a new endpoint. Right? You want a situation where a test fails when that happens. Right? So let me see if my only demo is going to work. Right? So what you want is a situation where basically here, if you look in this environment, right? Okay, so let's go like this. So this basically is my application. Actually, I should run presentation, but works. Cool, right? So this is my code on the left. This is my test on the right. So what you have here is a situation where my unit test is actually running in real time, right? See, I lift my hands, unit test runs, right? So if I go, you know, for example, AAA assert is BBB, you can see I just got a nice little test that says, hey, A is not equal to BBB. And if I go AAA, lift my hands, my test passed, right? This is the minimum requirement you want to do. As security AppSec professionals, your job is to get the developers to this stage, and they will love it for you for that. Here, I'm going to add a new route. I lift my hands. My test, which is here, which is locking my attack surface, failed, right? If I come in here and I add that particular path, right? We're in this particular situation, right? Which basically means I'm making it explicit, my test passes, right? The power of this is I now know when that file change, I need to do a security review, right? So that's the power of this. This gives you the second pipeline. Is the pipeline that says, hey, hold on, you just changed something that is important. You just changed something that has a lot of security properties. We need to review that, right? And that's when you do that kind of stuff. So again, that's TDD with Wallaby. That's the tool I was using, right? Again, that's a topic for another talk. So, any questions? That was just about, right? Yeah, so that's why you do that thing there, right? So so that step here, right? So this step here, where are we? Yeah. So the way you handle that, and I'll give you a really great case study for that, right? Is basically you approve it, but you have this timeout where the approval expires. So I'll give you a good example, right? We were working with the network team, and those guys they came out and said, hey, we need to create a root cert and give to the devs, right? And you go, hold on. Sorry, can you explain that again? Oh yeah, but we need to create all these testings, and we create all these different stuff, and they need to create, we have like bazillions of domains, right? So we're going to give them a root cert, right? And go, that might not be a good idea, right? That is trusted by the whole company, right? So they were working on it, and it got to the point where it became a block, right? So what we did was we said, look, we're not happy with that, but they were saying we can't figure out how to do it. The guys that were really experts were busy over there, so we said, look, we're going to accept the risk they're going to get that root cert, right, with a couple of caveats, but we're going to expire in 2 weeks, for example. That was a very specific case where we said, okay, we don't want that to be a blocker, right, but we don't want that to disappear, so we're going to give you that little interval, right? So usually, it's kind of like the things where 3 months time. So usually 3 to 6 months where we revise that. Because what happens is you make a lot of assumptions that change with time, right? So the way I look at it is that, even when the risk is approved, it doesn't stay there forever. Right? It kind of, you want that to be reassessed, right? In order to, what's it called? So you can look at it. And remember that we give weekly emails that says, here's the risks that you have approved, right? So it's not like it disappears. It's like it's very freaking obvious, right? And it gets really interesting when you have a vulnerability or a massive crash or problem that was caused by one of those. Right? That's where it gets really interesting. Where it says, hey, the root cause of that one was this thing, right? And we have 20 more of those that are currently accepted. So there you go. Can you defend that to your, boss because we knew about it and you chose to accept it. So that workflow works quite well. Oh, sorry.
What is the suggested workflow? So as a project team or as a software team, do I need to copy the ticket into my JIRA project?
Mm-hmm.
Or
Oh, so I just forgot I need to replay the question, yeah. So, okay, so the first question was pretty obvious, but the answer was the risk approval, right? So, okay, so the question is, what happens when there's the software team creates the ticket or copies the ticket, right? Yes, absolutely, right? So, what I found it works really well is that, they should have their own tickets with their own culture, with whatever they want to describe it. So they will create. So the logic is, here, so usually is when you move from allocated for fix to fixing, that's when usually they create a ticket. Sometimes they do it a bit earlier because they're thinking about it. Because what happens is sometimes you have one issue that's going to have 4 or 5 changes. And sometimes they might want to create 2 or 3 tickets for it. Sometimes you might have one ticket that fixes 4 or 5 things, right? So there's not sometimes a one-to-one relationship between what we raise here and what's on the code. So I like this because also what I don't want is that I don't want the developers to not be able to close their ticket. Does that make sense? So let's say they say, we need, this particular method has a security vulnerability, let's say it's not protected. There's an authorization vulnerability on this method. So we describe here, in a way, what happens is here, you tend to describe the feature, right? I.e. the problem. So here you say, I'm able to invoke this thing, and it has a side effect.
But you will reference the ticket?
Yes, absolutely. So you create, and that's one of the powers of JIRA, where you can link the issues very easily. In fact, I can see here, right, the status of the other ticket, right? So what I want is I want when the developers fix it, and usually they will say add security mapping, they'll be more specific, or they'll be very focused on the happy path. This is what you should do, where here usually you say this is what it does, right? And then basically you make them say this is, is now fixed, so now it goes into the test fix. So I would expect by you get to this stage that the thing is actually fixed, right? There's a couple questions here. Sorry? Yep. Yeah, but you have to remember that the first interesting metric is that just being able to write a test that replicates a vulnerability already represents a very mature test environment. I've found that most test environments, you can't do that. In a mature test environment, what you do is you write a test at the web tier, for example. Then you write the same test for the same vulnerability at the web services. And you keep going down, right, into the things. And ideally, what you should do is a reverse tree. Once you find the root cause, you go, hey, who the hell caused this guy? Can I still invoke the same vulnerability from here, from there, from there? Oh, bloody hell, there's another one, even bigger over here, right? So then you can start to think, where am I going to put the fix? So you have all these tests that if you can do the fix here, all these breaks, which is cool because you now don't have the vulnerability everywhere. So now you change all of this to regression tests. If you don't do it tests, you are still doing it, but you do it manually, right? So I found that this model, this workflow works really, really well because it allows you to, first of all, give the developers a much better brief. Here's what I think. Here's all the ways I can exploit this. So you speak in their language. You give them a way to replicate the problem, and they can understand. And then in a way, they say, hey, my job is to break that. I had experience where even me as a developer, you make a fix and then go, oh, shit, that didn't fix it, right? But you actually thought it did. But the test cases that you had actually were still some there, right? So it's a much more effective way to communicate. Okay.
How do you make sure that the developer doesn't get lost in JIRA issues? Because
Doesn't, sorry?
how do you make sure the developer team doesn't get lost in issues?
Oh, okay. How do you make sure the developer team doesn't get lost in issues? That's one of the jobs of the security champions. Right? One of their jobs. And one thing is actually I found that I recommend highly is hire a couple of graduates or people who want to get into AppSec and give them that job. Right? That's a great place to start. Because they're going to get their head around, they're going to learn a lot, right? But you do need to do that. That's something that, in a way, I actually sometimes have the AppSec Central team doing that a little bit in the beginning because I don't want them to freak out. So it's kind of, we maintain that a little bit. Eventually, it should just work by itself. In fact, you've done your job when new issues appear and disappear, and the AppSec team centrally didn't actually have to be involved. Yeah.
I spotted something there which isn't on JIRA. That's a very important thing.
Yeah.
Digital labels here.
Yeah.
I think it was on that slide. Here. Yeah.
This one?
Yeah.
Which one do you want?
No.
That one?
Yeah, this one.
Yeah.
So I've spotted there. You put OWASP top 10 against like A1.
Yeah.
Right? So, which didn't exist in JIRA. The cool thing about this, I'm just thinking, because for a person who is accepting the risk, is there a tool to look up that A1 in OWASP top 10? Because in OWASP top 10, you have a rating of exploitability
Yeah.
and impact. Because the person who is clicking accept risk button should say, right, how exploitable is this vulnerability and what's the impact? Because based on this, they can make decisions.
Yeah, absolutely. Yeah, so in JIRA, you do the same thing with labels. So when I talk about JIRA labels, you use the labels in the same way. So usually in JIRA, because there's so many labels, I tend to call AppSec : and then something. So in fact, it's quite cool because I actually want to publish the AppSec top 10 stats because we actually have them. We actually make up a couple new ones that don't exist in top 10. So like denial of service or some authorization stuff that is not there that we actually want to cover too.
But whose job is it to classify the issues in JIRA as almost?
Well, to be honest, it's the central team and the security champions, right? This is one of those where once you've done it, so one thing that happens is very interesting, is that you tend to have these issues that have really good documentation. So, for example, I remember once we opened a whole bunch of issues saying, we don't know the attack surface of these web servers, right? And we made every service accept that, and it was a bit of a shitstorm, right? Because they go like, what the hell, right? You're telling me I don't know? I said, yeah, you don't know, because where is it, right? Where's the attack surface? Where's the list of every single API that's possible on your application? And then what happened is, actually, one of the security champions wrote this really great, one of the tickets that explained why, the risk, the consequence, blah, 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 and then we all referenced that one. So it's a bit like, eventually you start to have these Uber tickets, but ideally what you also have is you have your Confluence or your wiki that becomes the source of things. So one of the things we also do, which I didn't show you here, is you basically create, for example, a Confluence page or a wiki page that talks about, let's say, one of the OWASP top 10, and then you point to the issues from there. Does that make sense? So that cross-reference is absolutely critical, right, for this. All right, cool. Any final questions?
Mm-hmm. You have your security champions, and they're maintaining this. So if you have an organization where product owners, so if there's a particular vulnerability that belongs to teammates,
yep.
then do you have to have a separate meeting where you have all the product owners where you're going through and you're saying these are the new vulnerabilities, expired, blah, 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 and then in the meeting they're saying, yes, I'll accept that risk, or no, I won't, or is it, because this seems like you're now adding a lot of process and it takes a lot of time, and most organizations, I know at Adobe we're this way, we're already blasted with all kinds of process and garbage, and this seems like it's just one extra step. I mean, I agree with everything you're saying to bring awareness of security issues, but if we don't get buy-in from management, they're willing to take this time for these extra meetings, then...
So the interesting thing, what I'm finding, which is, and also for me is part of the design of the game, is that when you look at this from a developer point of view, what you're doing is you're making it expensive for the business owner to add like all that extra features, right? So the very interesting game, especially when you do threat modeling, the very interesting game is when the developers realize that they can use the threat models to lock the briefs. I.e., when you have a new feature, you say, this new feature has a new paradigm, has a new pattern. Have we thought about it? If he hasn't, then we have to do a threat model, right? So what happens is you're mapping reality. You're basically saying, this is the reality of the situation. And what gets interesting is it doesn't take that much time because, in a way, the hard part is to create this, which is part of the job of the security champions, right? The very interesting thing is when you have team A with team B. So I had situations where team A was more than happy to accept stuff, right? But then team B going, hey, hold on, right? We depend on that, right? It's because if you, for example, have an issue where you take data from here and the data goes over there, which is basically not validating data, that's a risk, right? And the point of this is the risks should be very objective. Like, if you happen to have a 2-hour discussion or even a 10-minute discussion for this, that means the risk is not properly described, right? You need to make it easy to consume. But what you then have is a situation where you go, hey, team B, guess what? Those guys have these risks, right? So you now inherit those risks because that's yours too. And what's interesting about this model is you find that the best teams start to push security into the other guys. The best teams start to say, hey, I'm not going to talk to you, or I have a problem with that because you need to fix that because I'm not happy that I'm now in bed with you and you have these issues, right? So in a way, this is not a huge issue because from a timing point of view, it's the security champions and the security team that do all this. So in a way, the developers are not that involved. And the soft spot I find, which is kind of why I always go to developers, right, to the QA stuff, is because if part of your objective with this is to make the developers more productive, you start to gain a lot of time. Right? Because the logic will be that you're making the developers test better, so you start to have a bit of more slack time, a bit of more patience from the developers to do your stuff. So this doesn't add that much, right, to the whole workflow. In fact, what happens is you have much better discussions because, for example, let me give you this example, right? So we had this request where these guys were doing a fraud system, right? You can just imagine, right? When we says, what do you want? This says everything, right? We want everything that you have. We want from credit cards to emails to personal data to shopping carts, like the freaking thing. Like if it moves, we want it, right? Because, and I understand, they want to detect fraud, right? So we will start to list the issues. Well, and we do this on paper. Right? I do this on paper because at that stage, the threat model done on paper. So you're going to have that. Then we says, actually, what we can do? If we put an anonymizer service in front, right? You're only going to have 4 risks, right? And at that time, they haven't even mentioned the cloud, because I knew they were going to take all that data to the cloud, right? So suddenly it was like, actually, because we evolved sooner and because of the risks were much lower, they actually had a much better solution that suited them. See what I mean? So it's kind of like it allows us to catch the problem sooner rather than later. And what you're doing is you represent reality. And what happens is, if you don't have the time to investigate, then that's a risk, right? The risk is the team does not have time for security issues. Fine, I don't have a problem with that. But I guarantee you that that is going to backfire. But I left a line in the sand. Does that make sense? So what you want is to work with the teams that are more efficient, right, that play with you, and the teams that don't play, you go, fine, here's a risk for you. You guys don't care about security, right? That's fine, right? Let me just finish this with, so I was going to put this on the slide, but I didn't add, but let me just read you some of the security issues that I opened, which kind of I've opened in the past. So one of them is the protection only works when the attacker is not there, right? This is for SSL, right? So you have a man in the middle of protection that only works when the attacker is not there, right? And again, you have to be able to justify this, right? But it's true, right? You have man in the middle, which protection with SSL. If you don't have the security headers and you don't have the HSTS header, then you're relying on the fact the attacker is not there, right? The other one is the QA team does not guarantee that the tested website will work in production. That's a lovely one, right? Like you could already see the manager go, what? Because guess what? They don't have QA environments that match production, right? So you can't guarantee that the thing works, right? You can have security vulnerabilities that only exist in production, right? They don't exist in QA, right? So things like the bug fixes are random changes. Hey, you have no tests. They are random changes, right? You have no guarantee that that freaking thing actually is going to work, right? So like no test fails when the attack surface changes. You saw that. Internal users have access to all the customer data. Critical apps depends on hundreds of applications, right? For example, the thing where you have, for example, one app, one comment that puts every single thing inside the same domain, right? So /ABC, /app B, /app C. So you have 100 apps mapped to the same domain, which basically means that all embed together, which is great because when you find one cross-site scripting one of those, we go to all of them and go, hey, guess what? You know that great thing those dudes added over there for that particular website? You just compromise the identity, this, that, our assets, blah, blah, blah. And then suddenly things become a little bit more interesting, right? Right there, right? So, things like this, this is a good one. We have no idea if our known security issues are being exploited because we have no logging, right? The security model depends on us not being attacked. So this is the one where when you have enough vulnerabilities, you say, hey, our current security model is based on the fact that there's no attackers, right? That's cool, right? But that's our current security model, right? So, and okay, I have a pile of others, which I'll add to another blog post. But you guys, you get the point, right? This is a great way to have a very rational conversation about these security issues. I know, I do. I'm adding it to the thing. All right, guys. Well, thank you. I think we're a little bit over time, but thanks.